Let's discuss a question from theory of vibration. It is given that a 30 kg electric motor is supported by 4 springs. So you have a 30 kg electric motor. So let's draw it in the form of a square block, and you okay. So these are the springs. So these are four springs of each of stiffness 200 Newton per meter. Now this is a forced excitation problem. And why this is a forced excitation problem? Because the rotor of the motor is unbalanced, and the unbalanced force is usually in the form of F naught cos omega t. Okay, now this F naught is basically, so this force oscillates in this form, and it is basically due to the unbalanced rotor mass, and this is basically this force. Okay, so now this becomes so if you consider the entire electric motor as a mass, then this becomes a spring mass damper problem, and the damping coefficient is also given with the force varying as F naught cos omega t. Now how do you find out the magnitude of the peak load, which is F naught? F naught is basically, well, they have given that the effect is equivalent to a 4 kg mass located 60 mm from axis of rotation. So this is one way of categorizing the unbalanced mass, which is nothing but the equivalent force that is coming due to this unbalanced mass on the motor is basically the centrifugal force. This is a usual way in unbalancing of rotors. So this is nothing but m r omega square, and the m which is given as 4, r is given as 60, so let's write 0.06 into omega square. Well, the vibration frequency is the rotor is rotating at 10 radians, so that is the speed, actually speed of the motor, so 10 whole square. So this comes out to be 24 newtons. Okay, so this is the vibration force that is acting on the motor. So now analyzing this as a spring problem, so we have 4 springs. So each of the spring, they are all located in parallel, and each spring is 800. So the effective K, the effective K is nothing but, because they are in parallel, they add up and they become, so 4 into 200, which is nothing but 800 Newton per meter. So now how do you find out what is asked is how to find out the amplitude of the forced vibration. Let's first write down the amplitude of the forced vibration formula, which is nothing but F naught, the peak exciting force, by K equivalent by, you have the square root 1 minus omega square by omega n square, which is nothing but the natural frequency whole square, and this entire thing whole square, plus there is 2 damping ratio omega by omega n whole square. So all this is inside the root. Okay, so now let's substitute the values, and so F naught we already know it's 24 newtons. K equivalent we already know it's 800 Newton per meter. Omega n, how do you find out omega n? So omega n is natural frequency, which is nothing but your K equivalent by total mass of the motor. So that is nothing but 800 by your mass of the motor, which is 30 kg, right? So yeah, so putting all this, everything inside this and calculating, we get X as 10.7 mm. So this is basically an unbalanced force excitation on the motor, and so in a simple, this is a very simple model to analyze the motor vibration. So the amplitude 10.7, and the answer, the option is A. Thank you.